Delegates help you delegate tasks to other objects and provide better code reuse, which you can learn more in this video. Kotlin not only supports an easy way to implement delegates with by keyword, but also provides built-in delegates such as lazy, observable, Vetobol, and NotNow in the Kotlin standard library. Let's see these built-in delegates and how they work under the hood. But before that, I bet you like this video and want to subscribe to the channel, don't you? The lazy function is a property delegate that helps you to lazily initialize properties. That's when they are first accessed. Lazy can be really helpful for objects which are expensive to create. Lazy takes two parameters: a lazy thread safety mode enum value and a lambda. The lazy thread safety mode parameter specifies how the initialization is synchronized between different threads. Lazy uses a default value of lazy thread safety mode synchronized, which means the initialization is thread safe at the cost of a slight performance impact from explicit synchronization. The lambda is executed when the property is accessed for the first time, and its value is stored for future access. When checking the decompiled Java code, we see that the Kotlin compiler creates a reference of object type lazy for the lazy delegate. Let's take a look at the source code of lazy function. Since the lazy function uses lazy thread safety mode synchronized by default, it returns a lazy object of type synchronized lazy impl class. When the delegated property is first accessed, the getValue function of synchronized lazy impl is called, which initializes the property in a synchronized block. This guarantees that the lazy object is initialized in a thread-safe manner, but at the performance cost of the synchronized block. If you are sure that this resource will be initialized by a single thread, you can pass lazy thread safety mode none to lazy, and the function will not use the synchronized block during initialization. However, keep in mind that lazy thread safety mode none doesn't change the synchronous nature of lazy initialization. Lazy initialization still takes the same amount of time as non-lazy initialization of the object on the first access. This means objects which take long to initialize can still block the UI thread if accessed from it. Lazy initialization can be helpful to initialize expensive resources. However, for simple objects such as a string, lazy adds overhead by generating other objects such as lazy and kProperty. Observable is another built-in delegate of the Kotlin standard library. Observer is a design pattern in which an object maintains a list of its dependents, called observers, and notifies them automatically when its state changes. This pattern can be really helpful when more than one object needs to be informed when a value has changed, rather than having each dependent object periodically call and check if the resource is updated. Observable takes two parameters: the initial value and a listener handler that will be called when the value is modified. Observable creates an observable property object that executes the lambda you pass to the delegate each time the setter is called. Looking at the decompiled person class, we see that the Kotlin compiler generates a class that extends the observable property. This class also implements a function called afterChange that has the lambda function which is passed to the observable delegate. The afterChange function is invoked by the setter of the parent observable property class. This means each time a caller sets a new value for address, the setter will automatically invoke the afterChange function, resulting in all the listeners to be notified about the change. You can also see a call to beforeChange in the decompiled code. BeforeChange is not used by the observable delegate, but is used by the delegate, which is coming up next. Vetobol. Vetobol is another built-in delegate in which the property delegates veto rights to its value. Similar to the observable delegate, Vetobol takes two parameters, the initial value and a listener handler that will be called when any caller wants to modify the value of the property. If the lambda function returns true, the property value will be modified, else the value will stay the same. In this case, if the caller tries to update the address with anything smaller than 15 characters, the current value will be preserved. Looking at the decompiled person class, Kotlin generates a new class which extends the observable property. The generated class includes the lambda we passed in before change function, which will be called by the setter before the value is set. The last built-in delegate I'll talk about is delegates NotNow. NotNow simply allows a property to be initialized at a later time. NotNow is similar to latenit. In most cases, latenit is preferred since NotNow creates an extra object for each property. However, you can use NotNow with primitive types, which latenit doesn't support. NotNow uses a special type of read-write property named NotNowVar. Looking at the decompiled code, the full name property is initialized with the NotNow function, which returns a NotNowVar object. The NotNowVar class simply holds a generic nullable internal reference and throws illegal state exception if any code calls the getter before the value is initialized. The Kotlin standard library provides a set of built-in delegates, so you don't need to write, maintain, and reinvent them. Built-in delegates initialize fields lazily, allow primitive types to be initialized later, observe and get notified when a value changes, and even veto those changes. Thanks for watching. Go write beautiful Android apps with Kotlin, and I'll see you next time.